And welcome back once again to Computer Concepts Module 4, Operating Systems and File Management. This is part 1B of our lecture. And we'll go ahead and look at the outcomes. So in part B, we're going to cover these last two outcomes, which are explain the differences between the major operating systems and identify the desktop components. So let's go ahead and get started on that. When we last left off, we were talking about client operating systems. And just to reiterate, those are operating systems that are built for use on client computers being the desktops, your end user computer, desktops, laptops, smart tablets, two-in-ones, you name it, that's what we're talking about. Now, what we're going to talk about is server operating systems. So as you go out to say check your email with Outlook Web Access, Office 365 as you might know it, what's happening is that your browser is going out and hitting a web server, and that web server is hosting an interface that connects to an email server that houses all of your email, okay, or email for your entire organization. That requires a server. So you're probably by now, given the cloud, given its modernization, you're probably familiar with or have seen a picture of a data center with rows and rows and rows of servers, football fields long with servers. Well, they too need an operating system, and we're going to look at a couple of those here. I'm going to skip virtualization and go right to types of operating systems. So Microsoft Windows Server is an example. They have a standard edition. They have an Essentials edition, which is the smallest version, standard, and then Data Center. And Data Center gets up to handling terabytes of memory and massive processors so that the computer is very, very powerful enough to produce a lot of data or house a lot of data or process a lot of data in a very short amount of time. Mac OS, so we see Windows Server. It also, by the way, helps us with security. So it gives us a single sign-on possibility. You might be familiar with that at your organization where you can sign on to the computer and then you don't have to sign on to email and sign on to your intranet and sign on to other things. So it's also the security in that we can limit what people can access both on their local computer as well as via the servers or even in the cloud at Azure. Mac makes a version as well, so Apple makes the Mac OS server. So you can see the colors similar to here. So here is the interface of the Mac, and then we have Unix. Now, I know you hardcore Unix folks are saying Ubuntu is not Unix, and you're right. We kind of use the terms Unix and Linux, interchangeably. However, Ubuntu is a Linux kerneled operating system, and Ubuntu makes a server. The cool thing about Ubuntu server is it's absolutely free of charge. When we're talking about Windows or Mac, we have to pay a license fee in order to use those servers. So a lot of the web-based servers, because of the cost of Microsoft and Apple products, will use Unix or Linux-based open source software, i.e. server software, to create their server farms. Now, the challenge is, as we get into utilizing hardware has spanned so far past what most people need that we have a bunch of processing power and memory and storage and speed that is not being used. So what we're able to do is do what's called virtualization on the server or virtual server. In the upper right, I've given you an example of this. This is Microsoft's Hyper-V server, and what we're looking at is the server manager. And what you'll see here is that there's a thing called a DC. I know that to be a domain controller. There's another server here. There's an Exchange server, which is email. There's Office 365, Windows 2. There's Office 365, Windows 10. There's another domain controller for the lab, and etc. All of these are servers that are running on one physical box. That's what virtualization is. And remember, I talked previously about this. We can also do this on a client computer where we can virtualize other operating systems and run them. So commonly, folks that run Mac may run a virtual machine with Windows for things that they need to do or function via Windows. that brings us to sort of our last operating system. So we've talked about clients, we've talked about servers. Now let's talk about mobile operating systems. And the two primary players in this market are Android and iOS, iOS being Apple. A decade ago, Apple owned the market. Everything was iPhone, everything was iOS. Google came along with an Android operating system, and things have changed. Google has a lot of the worldwide market share with their Android mobile operating system. So realize, be careful when you hear this. Mobile operating system. We're not just talking about phones here, folks. We're talking about phones. We're talking about tablets. We're talking about computing devices that look like computers, but in fact are running Android or iOS because they have a portable keyboard with them, maybe even a portable mouse. So examples here, you'll notice in green is the interface and just a logo for the Android 10. That's a Google product. And then iOS is an Apple product, and that's in orange here for you to review. When we talk about components of a typical desktop, so we're not talking about Windows here. We're not talking about Apple, Mac OS. We're talking about in general. So the desktop is our workspace. Why is it called the desktop? Well, what was our workspace before the computer? It was the top of our desk. Everything was on there. And I went by the principle that a messy desk was the sign of a very sick mind. Just kidding. But, a messy desk, messy desktop. Get that? So what I've given you here is two examples. One is we're not looking at desktops here. We're actually looking at menu subsystems. But this right here would be the desktop, okay, you notice the arrow, for the Mac OS, okay? And then I've opened up the start menu in Windows and shown you that. So a window would be this right here, and we see these in both operating systems. We see them in all operating systems. This is what we're used to, is a window that opens up that leads to whatever's behind it. It may be a library, it may be a folder structure, it may be additional tools that we can use to manage the operating system. Up here, a menu, definitely different menus. We've got some menus here that we use. We have a menus here. Let's not confuse the menu with a taskbar. So a taskbar is where we can do a one click to open up a specific browser, file explorer, browser, whatever it is that we put down there in the taskbar, making it easier for us to get to common things that we do often within our client operating systems. Desktop components. So up here, I give you an example of a Mac dialog box. In this case, we're looking for increased security principle, which means we're running as an end user, and now it's saying, hey, before you can perform this, we want to make sure that you are who you are and that you actually have security permissions to do what you want to do, whether it be install a piece of software, delete something from the computer, whatever it is. It's going to call up a dialog box. In Windows, we see these. They're called user access control. It's a dialog box that comes up and says, hey, this software you're about to load, you click the executable. So we're just making sure you're loading software that maybe Microsoft hasn't approved, which means it doesn't have a Microsoft signature with the software. Okay? So as we continue to talk about software, each item that we create, like in Word, is a Word file. It's data files, Word, number, picture, whatever it is, specific file. If we're talking about creating 3D drawings, those two are files, okay? Data files, when we click on a file, it opens the program and then puts the file into the program so that we can manipulate it, start it, do whatever the case may be. So when you listen to music, that is a .mp3 file, for example, okay? Unless you're Apple, then it's a .ac. You get the idea. So file format. Now, how does the computer know what program to use to open a specific file? Well, it uses what's called a file extension. Now, these tend to be buried in Mac, and we can turn them on in Windows pretty easily. They're 3 or 4 letter sequence that is unique to that program. So I've given you some examples down here. exe, we would see at the end .exe, that's an executable. It's going to do something. Normally, it's going to install a piece of software, do something like that. Okay? We have flash files. We have hypertext markup language files. Those are the web pages. We use HTML to create web pages. Also, there's a couple example of standard file formats there, a .docx, which is the new file format for Microsoft Word, okay? It used to be just .doc, now it's .docx, the X representing extensible markup language, so a new means of producing content for the web for our computers. You're most likely familiar with the .jpg, which is a JPEG. It's a graphic file, and now we've seen those turn into .png, which is the new graphics format. It's higher compression, which means smaller formatted or smaller file size, if you will, with equal quality. Moving on, the folder, you're probably very familiar with these. I've given you example folders here and a library. So a folder is a name location on storage media. So why do we create folders? Just like in a filing cabinet, we had folders for maybe a client. Maybe we even had subfolders inside the client folder for their bills, versus their invoice, versus copies of their checks, whatever the case may be. So a folder is nothing more than a container we use to keep things together. This might be thought of in your garage as that storage box that has Christmas lights, and then right next to it is a storage box for Halloween stuff and a storage box for old records or whatever the case may be. As it pertains to a library is a special type of folder in which items are categorized. So we see here in my example in the upper right some libraries called music. Well, what it does is it goes out and it searches the computer. It finds all of the standard music file formats, file extensions, right, like MP3, brings those in so we can see all of our MP3 files in one place. We can see pictures in one place, videos, documents, you name it, all in one place. So think of it as a place of indexing common files. Let's go ahead and move on. Actually, we're not. That's the end of Part 1B. We'll be getting into Part 2. Let's just quickly look at what the outcomes for Part 2 are going to be. We're going to talk about how this magic operating system works. We'll look at the purpose of the operating system. We'll look at how it manages memory. I'm not going to spend a lot of time on this because we've already talked a lot about memory, RAM, ROM within the computer. The steps it takes to boot a process, we'll talk a little bit more about that in detail, and then operating system managing input and output. So we now know what input devices are, what output devices are. Now we're going to look at how the operating system manages those items. Until next time, have a great day and take care.